Okay, so we're going to continue picking up programming this lathe part. And I realized as I was setting up, actually not as I was setting this up, but after it was done while we were on break, I realized I broke my cardinal rule. When we were doing this lathe finish operation with the boring tool, what did I forget to do? Anybody? What do you always want to do before you start programming with the tool? Draw tool. Yes, yes. Draw the tool and axis combinations. Absolutely. So make sure left upper. Usually if you see left upper and that's what you've been programming with, it's not going to switch on you. Okay, so this is critical when you're doing like lower turret or sub spindle, because you always want to check that. If you're always on the upper turret, at least you know you're programming the first half of your part on the upper, you can be pretty okay with not checking it. But you always want to do edit tool and you always want to do draw tool. Okay, so this is how my tool looks right now. This is the holder that's been selected for it. This is how the tool is itself, and you can see there's not a whole lot of clearance here. So really, I need to adjust my bar. You know, I need to go into the boring bar here. I don't know what actual, you know, it's set to boring bar, but it's just using some weird bar. So let's go get bar. Oh. Oh. Let's see if any of these are small enough. 625. You know what, we're just going to adjust the size of this thing. Let's go 3 inches long. These center lines like 0.14. And the thickness, let's make that 0.25. Huh. That's interesting. What insert I have set here? I have 30 seconds. All right. Let's go see what other ones we've got in here and see if any of these are already set up. I apologize for not having the tools set up ahead of time. That's probably something I should have done. Let's go draw the tool. See, here we're showing the insert. And like that one's not too bad, but the points are a little funny. Should probably talk about this. When I do draw the tool, there are some clearance angles that get used, and we need to make sure that they're set right. The way that it works is you always have a little circle at the tip of the insert, and then you typically have a purple circle that represents the clearance line off of the Z angle, and then the other one represents the clearance off of the X angle, and you can see that it's actually way down there. So this whole thing, we need to go over this real quick. Let's go Inscribed Circle, 530 seconds. Looks like it's 5/64 with a 0.5 over 64 corner radius. So what is that, a 1/28? That seems silly. All right, let me draw tool. Now, one thing that we can always do is to draw a custom tool where we draw the shape of the insert and we draw the shape of the holder, and we could use that instead. So just keep that in mind. We go like 1/16 on the insert thickness. I'm surprised it only goes down to 5/32. That's okay. So what we'll do here, we're going to go to the boring bars. Right now we've got a 1-inch wide bar. C says it's 1.042. See, there we go. So there's the bar itself. We're going to go the A dimension. We're going to go like 0.15. The C dimension, we're going to go like 0.25, and we'll do draw the tool. So I don't know what it's going to let us get down to. Okay, so if that's true, let's go like 0.18. Actually, A should be the width of the bar, and then C should be half of it plus C could be much smaller than A. Yeah, let's go 0.1, something like that. Draw the tool. Now our insert's pretty big, so let's go 0.3 on there. Let's go 0.12. Draw tool. See, it's still not giving us what we need. Let's see if any of these bars are small enough. Does anybody know offhand if any of these boring bars are fairly small in the catalog? No. All right. So we're going to do a custom one then, because that's what we really want. So if we go custom, we're going to be able to create our own geometry, and we have to tell it how the tool is oriented in the turret and what the size and shape of the tool is and all that stuff. So when we go to create a custom tool, we need to follow the rules that are in this catalog. So let's see. Use this tab to establish the geometry of a custom or non-standard lathe tool, which cannot be properly represented with one of the standard tool types. Select a geometric tool orientation to set how Mastercam should interpret the tool profile geometry. Choose the location, etc., etc. C. Defining geometry for a custom lathe tool to learn more about the geometry requirements. Okay, so you can do this two ways. You can either have a separate Mastercam file, or you can use a separate level in the current Mastercam file. So, I can certainly show it both ways. I think in this case, to cut down on time a little bit, we'll do a separate level in the current Mastercam file. If the file is located on a level in the Mastercam session, then the tool insert and holder geometry must be the only geometry on that level. The geometry must meet the following requirements. It must consist of two closed boundaries, one for the insert and one for the holder. It must consist only of lines and arcs. The insert must be drawn in one color, the holder must be drawn in a different color. Once you have the insert and holder geometry saved to a file or to a specific level, you can begin creating the custom tool using the Lathe Tools dialog box. Important, it is strongly recommended that you use the default inserts and holder colors. The default colors are 14 for the insert up, and 138 for the insert down, and 116 for the holder. Settings, configuration, and choose the colors property page to set the default colors. So notes, if you are defining a custom tool that is mounted at an angle in the turret, The tool geometry should represent the tool mounted at 0 degrees. You can then define the angle in the lathe tool setup box with the tool button. I get something from Corey, lathe inch.tools tool 2222. Okay, so we could definitely do that. Let's continue with creating the just a custom tool, just so that everybody's familiar with how to do it. Let's see. If you were defining a custom tool that's mounted at an angle, we talked about that. When defining a custom boring bar, you should use orientation 4, not 8. When creating the profile geometry for a custom round shake turning tool, make sure you create it in 2 separate sections. A closed rectangle for the shank and the profile for the head of the tool. The closed rectangle is necessary because Mastercam requires a dividing line between the shank and the head of the tool as shown below in order to revolve the rectangle into a round solid for the shank. Okay, so we're going to actually have, it sounds like a profile for the head of the tool. It sounds like we're going to have 2 separate sections for the holder. So in reality, we need 3 boundaries. So we'll just keep that in mind. So that's what we're going to do here. We'll save where we're at. We're going to go create a custom level. I tend to use numbers for my custom tools that are out of the range that I normally use for parts, so that I don't accidentally mess with them. So we're going to say this is custom boring bar, maybe TO303 or something like that, because we're going to make it tool 3. And, you know, this might be from Micro Cut or Micro 100 or somebody like that. So we'll turn everything else off. And when we draw it, we need to draw it in the orientation that we're going to use it. So what I'll do here is create a line. We'll give it like 5 or maybe 7 degrees of clearance. So let's go 275. Let's go 277. Okay. We're going to take that line and rotate it. We got a question from Roger. Will this tool only be available in this Mcx file, or can you save it to a library? You can do either, but you need to figure out what you want to do first. In other words, if I save it in this file, it's only available in this file. If I save it to a library, I need to create a whole separate Mcx file that has only that geometry in it. So if you do want to be able to use it in multiple files, that's the way that I would go. Okay, so if we're going to do that, let's not worry about having this here. Let's just save it. We'll delete that level. Purge empty levels. There we go. Purge empty levels. There we go. All right, and save this. So we're going to do machine type design, file new. And we're going to do file save as. And then we need to choose the location of our library. I'm just saving it to this particular folder. We might call this hey, no, Josh, that's no problem. This happens all the time, you know, and what part of the reason that I'm doing some of this stuff live for you guys is I want you to see what happens in the real world. You know, it's one thing when somebody comes out with some slick can demo and everything is all set up right, and they're like, oh, look, it's just so easy, right? That always happens. Everybody's like, oh, yeah, no problem. I do this all the time. But, you know, sometimes you have to go through this work to get the job done, and it helps sometimes to think about how are we going to set up and use, you know, all of these tools across multiple parts, across multiple machines, you know? So a lot of the times taking time up front and setting up your tools so that you know they're there and you know how they work is worth it. You know, so we're going to do custom boring bar, maybe T0303, micro 100, and maybe we want something like min bore 0.160 or something like that. And we'll save that. So now what we're going to do is create that insert geometry. And keep in mind, with the custom tool, we have to create this as an insert, even if it's just a solid carbide boring bar. Okay, so keep that in mind. What you're doing by creating the insert is telling it that that is the portion that is allowed to cut material. Okay, so we're going to do maybe like 277. We'll make this 0.1 long. And actually, let's rotate that. Rotate it, copy it, maybe 35 degrees. Okay. There's nothing that says the insert, I believe, has to be like a parallelogram or rectangular. So, but what I'm going to do is just kind of connect it like so. Actually, before I do this, what I want to do is say, all right, if this can fit in a bore that's already 160 thousandths, let's get a line that's also 160 thousandths. So we'll do that. We'll do point, maybe like 155. Let's go 0.145. Something like that. That looks okay. And now what I'll do is do another line that's down here like this. Let's say that's 300 degrees. And we'll just go with the intersection there. That's fine. So that's going to be, actually, just want to get rid of that one. Okay, that's going to be the insert itself. Now, when we do this, we need to determine whether we're doing insert up or insert down. It really just depends on how you have this mounted, right? Is the body of it up or down? For a boring bar, it kind of doesn't matter because we end up doing a round shake anyway. But it's just something that you're going to want to be aware of. You know, we need to check the insert color. So yeah, the colors are already there. Era says he usually picks a tool close to my custom tool and save the geometry and then edit my tool and holder. The colors are already there. Absolutely. That's a great idea. So insert up, let's just define this as insert up. We're going to do color number 14. So I'm going to grab that geometry there, right click on color and just type 14 right into that box. So you can type that in if you want. Now we need to essentially define the head of that boring bar. So what we're going to do is do color 116 for the holder. So I'll just grab the color here, type in 116, and now we're going to do a line that's up there like that. We're going to go, actually, no, that's fine. We're going to leave it the length there. I'm going to do a line that's up here, maybe to the midpoint. Okay, and what we're doing here is we're defining the head of that boring bar. So I'll do this out here. Right now it's 0.355. Let's go maybe 0.85. I forgot how deep that bore is, Josh. But let's say, let's say that if this is a small bar for a deep bore. We're going to go 0.85 like that. I'm also going to do one down here. We'll just go a little bit extra long. And then we're going to trim these two together. Okay, so I really don't need this line anymore. 0.798. Okay, 798 on the board. Then what we'll do is we'll just go translate. Actually, no, I'll just do this. Create line endpoint. We're going to do a vertical line, and we're going to say that's at 1 inch. And we're going to trim all of these guys together. Okay, so this is the head of my boring bar. Now I want to make the section that's round. So what I'll do here, create a line endpoint. I'm going to go up there and we're going to do the length of the line. And let's say that this thing's got like a 3/8 shank, so 0.1875. And then I'm going to do trim and extend 0.1875 and click on this line near the end. So now it's kind of double. And now let's go out there. So that's 1 inch. Let's say that this tool is, I don't know, 2.5 long or something like that. So we're going to go 1.5. There. So what this is going to give us, this should give us what we got down here, right? There's the round shank part of it, and then there's the head section of it. Okay, so now I'm going to save this. And again, we need to think about where we're going to put that tool. So this is going to be my custom boring bar. We'll go min, how about how we want to designate that. I don't know. Maybe we have some kind of system where, you know, it's an implied decimal. Okay. So we got that saved. Now we go back to our part that we were working on. And now we're going to go Toolpaths, Lathe Tool Manager. Going to right click and say create a new tool. And we're going to do a custom tool. So here we get a choice of a file or a level. We're going to choose file. Oh, and the other thing that I didn't do on there was put a radius on the corner. I probably should have, but that's okay. MP201 custom boring bar. We'll say open. So there's our custom tool geometry. Insert corner radius in inches. I'll put like 2,000. For the tool center, what we're really looking for, so there, let's see, tool center, if I go look at tool center, field definitions. Display the tool in the graphics window. When prompted, select the tool's center point. Mastercam displays the coordinates of this point in the tool center box directly below this button. Great. Thanks for telling me nothing about what it's used for. First thing we need to do is set the geometric tool orientation and the tool orientation in the turret. If we go back to defining a custom tool, defining custom boring bar, you should use orientation 4, not 8. Oh, if you have the rad drawn, it will allow you to pick the center. That's right. So it's the center point of this insert radius. If we do tool center, what we should be able to do is hold down Shift and click. Oh, it won't let us do that. That's okay. So we got 0, 0, 0, 0, tool center. How about we go 0.001 in X, comma, minus 0.001 in Y. So now we can enter those values. All right, so orientation 4 is what we want for our tool, not orientation 8, and that has to do with the direction of cut and the plunge direction. You can see there's 2 different colored arrows there. And we will also want tool orientation in turret also selected as option number 4 here. Okay, now we go tool type, custom tool classification. It is a boring bar, insert material. Okay, so if it was a threading tool, you could give it threads per inch tool diameter. In this case, we're just going to go carbide. You know, there's unknown, there's a bunch of stuff. Parameters, tool number 3, that's what we're defining this is. Station number 3. Inches per revolution. 2.5 maybe. Plunge rate 2. Spindle speed. You know, we can enter all those parameters there. Tool clearance is a good one here. One of the things I can do for these end tool and side tool clearance, you'll notice here that it shows a picture of the insert. So we've got the width of the insert and the end clearance angle. Okay, so end clearance means clearance on the bore, right? On the wall of the bore. The height over here is used to determine the side clearance angle. So we need to define the width and the height and the clearance angles. And one of the easiest ways to do this is use the from lines. So I'm going to go from line, and I'll choose that line there. And you'll notice that gives me an end clearance angle of 48 degrees. But the width, when we describe that width, what we really want to do is from 2 points. Okay? And you have to be a little careful here because sometimes you'll grab 2 points like this. I think if we do that, if we go, you know, point here and then this point here, I don't think it's just going to grab the X width. You know, I think it's like the 3D distance, and we may not want that. In this case, it really won't matter, right? Because we're typically just cutting with a little bit of the insert anyway. How about scan the tool? Sure. If we just do scan tool geometry, what we get now says this geometry scan is complete. The current tool definition may not match the geometry. The system suggests the values listed below. Select the items you wish to change. Geometric tool width, 0.066, so it's probably gathering the width all the way across there. Geometric tool height, 0.145, okay. Geometric side clearance, this side clearance, 42. Geometric insert corner radius, 0. It's suggesting that because that's what it got off of the tool geometry itself. Tool width, tool height, and end clearance angle 48. You notice it didn't suggest anything there, and so it's suggesting 42 degrees. If I select OK here, and we go in there and say OK, and do draw the tool, that's giving me the compensation point because I told it that we have a radius. Oh, now it set it back to 0. Okay, that's good. So 4, tool type, parameters. If we go back to tool clearance, and let's pick from line. Oh, there we don't see it. Hold on, I'll hit escape. So there's the height, there's the width, there's the clearance angles. Okay. I don't know if it only shows the compensation points when you have a radius on there. It may, but when I do draw the tool, what I usually expect to see is those little clearance circles that tell me I've got things set up right. So we may do end clearance angle, how about 15 degrees? How about side clearance angle, 7 degrees? Okay, because that's what we set it up as. The height, let's do 0.1, okay, and the width, because what we're really doing here is we're looking to see these little arcs drawn, okay? And again, this may, let's do 0.06 on the width. But this may only display if we've got a radius on the tooltip. So I'm going to go back into geometry and we're going to go insert corner radius 0.02, tool center, spacebar, about 0.015, and 0.0015, comma, minus 0.0015. And now if we do draw tool, I get what I'm expecting to get, which is these little clearance circles which show me where the tool tip is and where my compensation points are. So I think you have to have this insert corner radius if you want that to work. So most likely you've got some kind of radius on that tool. It's probably not going all the way to a theoretical sharp point. In this case though, I don't like doing this only in the fact that I really want to draw my tool as it actually exists. So if we have a tooth out radius, let's go put that on, right? I'm going to save where we're at. Let's go back into the boring bar tool. Now I want to draw in yellow. My current color is 116 because I want to edit the insert. Alt X on the keyboard. If you hold down Alt and press X, it now says select entity to get main color, level, style, and width. So I'll just click on that, and now it'll reset, my level, my color, all that stuff. So now I can go in there and do fillet. I want a 0.002 radius. Okay, and that's why you notice that when I said that, we need to know where this real radius of this tool is. Now, typically, one of the things I will also do after I've drawn the tool up like this, I really like to make that radius tip tangent to that origin. So what I'll typically do, draw my lines like this. Okay, so I've just drawn a couple of lines, and now I'll do create a line closest. So I do that line and that circle. I do the command again, that line and that circle. Okay, and now I know I need to move all the geometry let's just grab it all. And we're going to go translate. Xform translate. We're going to move it. The X is going to be the length of an entity. I'm going to grab that line right there, and it's going to be that distance. So we're just going to put a minus sign in front of it. And the Y height is going to be the length of an entity, that guy right there. And I'll say OK. So now I can just get rid of all that extra. And my tool is now tangent to that origin. Okay? So I'm going to save those changes to my tool. Okay, save it, yes. Now we're going to go back to our part. Okay, and again, we're going to do lathe finish. We're going to go back in here, and we're going to go create a new tool. All right, so we're doing a custom tool. We are doing this custom tool boring bar, tool 0303, number 4, tool center. I can actually go grab the center point of my radius now. Okay, and it pulls in these correct values for me in Z and in X. And now we can go tool type. It is a boring bar. Parameters. Tool 0303. Feed rate. Maybe 1.5 thou per revs. Maybe not. Maybe like 0.8. 0.8 per rev. I don't know. It's a small tool, right? Okay, spindle speed, probably be more like 800 surface feet. I don't know. We'll leave it at 200 surface feet, that's fine. Amount of rough cut, finish overlap. Amount of rough cut on this guy, maybe 10 thou. Amount of finish cut, I don't know, 1.5 thou. Oops, more. Amount of overlap, 5 thou, that's probably fine. Retraction amount, overcut on face, 3.5 thou. Okay. All right. So we've got all those set. Now we do tool clearance. End clearance. Remember that this is going to be, we're going to do like 15 degrees, 60 thou width. Okay, side clearance, we're going to do 7 degrees, and we're going to do 0.1 for the height, maybe 0.09, something like that. And set up the tool. Okay, it's a horizontal tool. It is on the top turret. It's on the left spindle. You'll notice that there's something up with our settings here. We may need to do, reverse tool, or we may need to go back into the holder, tool orientation and top view, primary cut, primary plunge, orientation in turret. 4 should be working for us. I don't think we should usually flip that around. But again, if I pick horizontal, I pick top turret, left spindle, everything looks good here, and I do draw tool. Okay, it's set up correct. That's exactly what we want to see. 15 degrees isn't really the right amount of clearance. We should have a lot more, so we can go in there and adjust that a little bit. We go back to tool clearance. How about we go 35 degrees and we go 50 thou on the width. Let's see what that gets us. Oh, pretty good guess on my part. We're getting close. Okay, so we're going to go back to, I think it was 48 degrees actually was the amount of clearance on there. But the width, let's go 0.04. Okay, so the angle is right, but the position of this, and this is all really just used to, create a boundary for this tool as it's doing its cutting and making sure that the clearance motion works. So, like, for example, it won't allow you to make a cut that exceeds those clearance values. Okay, so if you were like plunging you know, you're inside a bore and you're cutting the interior part, it's not going to let you do a plunge that's like vertical because it knows the insert can't cut a wall like that. You're limiting what your cut can be. So the only other thing that we might want to do there is go like 0.03, draw tool, and that looks a little better. Again, we want to keep this, you know, the amount of this clearance pretty consistent so that we can make sure that we're not exceeding the capabilities of the tool. All right, we've finished. This is going to be Lathe Tool 03. This might be, you know, micro 100 and some tool number, right? Some part number. Okay, so we've got all that set up, got all the parameters set. We now say okay. Left upper for a combo, that hasn't changed. We're still good there. Now we want to do reinitialize speeds and feeds, and you'll notice that we get our correct values imported. Max spindle speed, I don't know what it is on this machine, but you know, if it's above 4,000 or 4,500, I'd be surprised. You notice we also have feed rate in micro inches. So, you know, if we're using a real fine feed or we want to be able to control it based on the finish that we expect, we can enter that as well. Anyway, we're going to do finish parameters, finish step over. How about 0025? Oh, that's right. That's right. We're cutting the other way. So finish direction. Okay, this is an important part of doing boring. We got to determine how we're cutting. You notice that we have, you know, cutting along this way. We have cutting on the outside. Oh, sorry, these are the four choices. So OD, ID, face, and back face. So just keep that in mind. We are cutting on the ID. Lead in and lead out. Okay, our entry vector, our exit vector, we've got that stuff set. Plunge parameters is a good one. Okay, all of the tool paths for the lathe have these plunge parameters that determine when we're following geometry, do we allow plunging? This is no plunging allowed. This is allow plunging in both directions. Okay, this is allow plunging in relief only. This is allow plunging in undercut, but not along the face. All right, and then if we're doing any of these plunge options, you notice that we can also control the front and the back clearance angle, so that if we're going down into a relief, you know, we can determine on the front, are we starting on the front corner of the tool, or are we starting the cut on the back corner of the tool? So we have some of these options as well. All right, let's go ahead and say okay. Oh, and one more thing we needed to adjust. We're inside this bore and we cut a line that's vertical right here. Our tool needs to be on the right side of that line. We've got our compensation set to the left, and you can see the circle over here, and that's not going to work for us. So we really want to go right and select OK, and then regenerate. So based on our retracts and all that stuff, you'll notice that, and potentially the orientation of our tool here, that we don't have enough clearance. So it's on these retract moves, you know, that were, and the plunge moves that were causing some issues there. So what we'll do is go back into the lead in and lead out. For the lead in, let's see, resolution 45. So for the lead in, we're going to try 180, see what that gets us. Lead out, and one of the things we got to look at is our length here. So see whether that's doing it or not. Let's see, minimum vector entry. Let's see if we can figure it out with the automatic. Do automatic minimum 5,000, and see if that gets us anywhere. Huh, cannot compute. So, what we may end up needing to do, because some of these lines are so long as we're making these cuts, is we may need to create some custom pieces of geometry. You know, a smaller line here, a little bit longer, to make sure that we can get our bore in there. The other thing is that tool may just not be very well suited, right? I only drew it with 7 thousandths of clearance on that front edge, so we may need to come up with some tool with more clearance to allow us to cut in here. Okay, so we're going to continue next week with getting that custom tool figured out. We'll get that all dialed in and clean up the interior of this bore, and then start doing the milling tool paths and talk about that. While we were on break, I was doing some thinking, and the reason that the cut type was not working for those mill tool paths and we weren't getting any motion out is that the plane that we use for any C-axis work in this post has to be based off of the back plane. The back plane's x-axis is reversed from the top plane. So I'm pretty sure that's why we were doing that that cross cut in the y-axis and we weren't seeing any motion coming out, because we had it set to the top tool plane, and really we needed to have a back tool plane based tool plane. So we needed to take the back tool plane and rotate it 90 degrees, and that would have created a new tool plane for us, which should have given us correct output. So we're going to be looking at that next week as well. So are there any questions so far about what I've gone over for setting up these lathe tools, setting up stock left or right spindle work? Let's go ahead and open up the rest of the time now for questions about anything we've talked about today, and then we will, be continuing on. I do want to mention a couple more things, what you guys think about if there's questions. I'd encourage everybody to go and log in to the eApprentice website. We've got that up and running, and we're I believe the first video has been produced. I'll make sure that Micah uploads it to the website. But if you go in here and go to My Courses, you should see one for Mastercam MP Post Processors Lathe. And when you come in here, once the first video has been produced, it'll be uploaded. You'll notice that I've already uploaded the sample files that we worked on from that first class. So we do have a zip file that's in there that you can take a look at. There is also, let's see if I can find it. If we go to there. If we go to General, you'll see that there's a news forum in here. And so you can go to the news forum, and I put the first topic up here, just say, please use this forum to chat about our class, ask questions, share tips and tricks. So, and you'll notice that when you go in there and you look at that first one, I've got a zip file here for the tailstock example. So last office hours, last Wednesday, I think it was Craig. Was it you, Craig? Somebody was asking questions about how to use a tailstock in Mastercam with their post. Yeah, it was Craig. Okay, great. So I uploaded the sample files that we worked on in zip format into this forum. So if you go and log on to the website, eapprentice.net, and you go to your MP Post Processors Lathe course, there is the news forum. Looks like it's right up at the top. You can also get there under General. And when you go to the news forum, you'll see the length you'll see the link here to this discussion, and I should put in there that also includes the tailstock example. But there's that tailstock sample files. So for those of you that weren't there, we talked about how to engage and disengage the tailstock, and also how to make it work to output a macro when there's a miscellaneous integer enabled. So we talked a little bit about how to control output based on what we're setting in the interface, and how we can modify the post to do that. Good. I'm glad you got it working, Craig. That's the whole point of this class, is to make sure that everybody has the tools and the skills needed to get the output they need for their equipment. I mean, that's the whole idea. So I'm glad you got it working, and we'll be doing some more of that as we go, throughout the class. So I just wanted to point that out. Go ahead and use this news forum on the site. If you want to ask questions, if you've got questions about how do I do this with my Lathe Post, I'm working on this. Create a forum about this. When you do, when you create a new blog post or a new post on the forum, if I go to forum here and we say add a new topic, this is going to be just test. Okay. What I wanted to show you is that we've got this section here to add a file. It is only going to let you add one file. So make sure that you put everything together in a zip, and you can just drag it and drop it. So if you're in, class like this, and you say, oh, here's my tailstock example, you notice that you can just drag it. If I hold down Control as I'm doing the drag and drop, you can copy instead of just moving it. So I'd encourage everybody, if you've got a problem, put a subject, put a title of what the problem is, give me a message about what's going on, and then that way, when I respond, everybody can see my response. Because one of the things I've been looking at is that, people ask these questions during class in email, and I respond, but it's only it's only good for that one person. And I think there's a lot of questions and answers that I give that are going to be beneficial to everyone. So I want to encourage everybody to use this news forum feature. And as we add, let's just leave that page. As we add both the videos and the descriptions for these classes, we're going to be, filling this in. So please do use the website and this news forum. Communicate back and forth with class issues. And like I showed, you can use it to upload your files as well. So I just wanted to point that out for everybody. Any questions before we wrap up for the night? It is possible to import solid models of a custom tool and extract 2D from that if you get it from the manufacturer, but there is no ability yet to use solid tool geometry in the custom tool. So you have to have 2D. If you've got an example, Roger, that you can post up on the news forum of some 3D geometry that you want to work with, like if you actually have some 3D models from a tool manufacturer and you'd like me to show how do we create a custom tool from that, I'd be happy to. But currently we don't do, in Mastercam, we don't do 3D modeling of the tools. We are working on it. I know that's one of the things the tool guys are hard at work on, is how do we support these 3D definitions. It's not, I shouldn't say it's not as important for mill, because of course it is important for mill, but it's really critical for lathe, right? Because a lot of times we've got these funky, very big and thick tool holders that have kind of like multiple pieces and multiple angles to them. And it's going to be really important for us to be able to show that and simulate that. So I know they are working on that. But again, if you've got an example that you'd like me to, to show or to take a look at, go ahead and post it up to that forum. on the eApprentice site. And that forum is for our class only, by the way. Yeah. If you draw them in SolidWorks, go right ahead. That'd be great. Just send me the post up the SolidWorks file, create a new topic on the forum for eApprentice. When I say the forum here, I'm talking about, this news forum for eApprentice. And we'll take a look at that. Be happy to. Good question, by the way. Yeah, absolutely. Thanks, Roger. So, anything else before we wrap up class? All right, I think that's just about it. Thanks, guys. Thanks for coming. The next couple of classes, we're going to start to delve more into the post side of things. Right now, we're just, doing the common foundational stuff, making sure everybody knows how to define the tools and set everything up and troubleshoot, because that's a big one. I'm working on it. Something says it's not right. How do I go in and fix it? So, but yeah, we will be getting more and more into the post side of things as we go along here. So thanks, everybody. Thanks for attending. I'm going to go ahead and shut down the broadcast. Again, thank you all, and I will see you guys on next Wednesday, for those of you that can make it. Remember that office hours is not required, so if you can't make it, it's okay. We do the recordings and you can view it later. Otherwise, I will see you guys either Wednesday or Saturday. Thanks, everybody. Appreciate it.